The Fourier transform has many applications. For example, it's used in quantum mechanics, audio editing, and data compression, but intuitively understanding how the Fourier transform works is difficult. Imagine two waves that have been combined into a new wave function. The Fourier transform allows us to decompose or unmix these waves into their constituent frequencies. By using a complex path to define our function, we can decompose it into a set of rotating vectors. In this diagram, the white lines are the vectors rotating at a constant rate inside the gray circles. By summing together more and more of the vectors, you can get a function that is arbitrarily close to the original path. This only works as an animation, as without motion, the concept of a rotating vector becomes meaningless. The problem with these approaches is that they do not show the time axis. Instead of representing the complex Fourier transform as a two-dimensional path, what if we represent it as a three-dimensional path, with time as the z-axis? For example, a circle being drawn by a rotating vector would now be represented as a helix. Thinking of it like this, how could we find the frequency, which in this case is the number of loops in the helix? One idea is to untwist or unwind the helix. To do this, we rotate each position on the helix by a twist constant multiplied by the position in time. The effect of this is the farther you go on the helix, the more each position will be rotated back, which untwists the helix. When the twist constant matches up with the frequency, the helix will be wholly untwisted and become a line. However, at this point, what we're doing isn't very useful, as we're only detecting the frequency of a single helix. So now let's move on to two helices summed together. Here we see multiple views simultaneously. Here we see it hit the first frequency. As you can see, it has formed a helix that is slightly shifted to the right. By showing multiple helices or waveforms added together, and showing the helices being untwisted, this demonstration is more intuitive. It shows the entirety of the Fourier transform operation at the same time. As nothing is hidden, the learner is not left to assume information, making concepts easier to understand. Future extensions of this work could include features that allow the user to use custom paths, making it possible for a general user to utilize its entire functionality themselves.